According to the National Electrical Code, the maximum allowable ampacity for American wire gauge number 10 copper conductors in air or outside is 30 amps. Therefore, American wire gauge number 10 is not suitable for carrying 40 amps, even if the voltage drop is within acceptable limits. Using American wire gauge number 10 wire for 40 amps poses several safety concerns. The wire may overheat due to excessive current flow, potentially causing insulation failure and fire. The wire may experience a significant voltage drop at full load, reducing the performance of the SPA and its components. Installing an electrical circuit that does not meet National Electrical Code requirements can void warranties and insurance coverage. For a 40 amp 220 volt SPA located 80 feet from the power panel, the recommended wire size is American wire gauge number 6 copper, which has an ampacity of 55 amps in air. It is always advisable to consult with a licensed electrician to ensure proper wiring and safety compliance. The National Electrical Code, or NEC, sets the standard for safe electrical installations. Understanding ampacity is crucial for preventing electrical hazards. Ampacity refers to the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. Several factors influence ampacity, including the conductor material, size, insulation type, and ambient temperature. Copper and aluminum are the most common conductor materials. Copper has a higher ampacity than aluminum for the same gauge size. Wire gauge is a measure of the wire's diameter. A smaller gauge number indicates a larger diameter and a higher ampacity. For example, American wire gauge number 6 wire is thicker and can carry more current than American wire gauge number 10 wire. The insulation type affects a wire's ability to dissipate heat. Some common insulation types are THHN, THWN, and UF. THHN and THWN are typically used for dry and wet locations respectively, while UF is suitable for direct burial. Ambient temperature refers to the temperature of the surrounding environment. Higher ambient temperatures reduce a wire's ampacity. The NEC provides correction factors for adjusting ampacity based on ambient temperature. Voltage drop is the decrease in voltage along a conductor due to its impedance. Excessive voltage drop can cause appliances to malfunction and reduce their efficiency. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Voltage drop is influenced by several factors, including the conductor's length, current, and resistance. Longer conductors have a higher resistance and greater voltage drop. Higher currents also increase voltage drop. Larger gauge wires have lower resistance and less voltage drop. To calculate voltage drop, you can use the following formula: voltage drop equals current times resistance. Resistance can be calculated using the formula resistance equals resistivity times length divided by area. Resistivity is a property of the conductor material. Length is the length of the conductor in feet. Area is the cross-sectional area of the conductor in circular mils. Ensuring proper wiring and safety compliance involves several steps. Firstly, determine the correct wire size based on the load and distance. Consult the NEC ampacity tables to find the appropriate wire size. Secondly, calculate the voltage drop to ensure it is within acceptable limits. Use the voltage drop formula or online calculators. Thirdly, select the correct insulation type for the environment. Choose THHN for dry locations, THWN for wet locations, and UF for direct burial. Fourthly, ensure proper grounding to prevent electrical shock hazards. Grounding provides a low resistance path for fault currents. Fifthly, use appropriate overcurrent protection devices, such as circuit breakers and fuses. Overcurrent protection devices protect the wiring from overheating and causing fires. Lastly, follow all applicable codes and regulations. The NEC is the primary source of electrical safety standards. Here's a more detailed explanation of ampacity. Ampacity is a crucial concept in electrical engineering and safety. It's the measure of how much electrical current a conductor, typically a wire, can safely carry before it risks overheating and potentially causing damage or a fire. Several factors affect the ampacity of a wire. Firstly, the material. Copper and aluminum are the most common materials used for electrical conductors. Copper generally has a higher ampacity than aluminum for the same wire gauge, meaning it can carry more current without overheating. Secondly, the wire gauge. The wire gauge refers to the physical size or diameter of the wire. It's measured using the American wire gauge system. Smaller gauge numbers indicate larger wires. Larger wires have a greater cross-sectional area, allowing them to carry more current. Therefore, a lower AWG number corresponds to a higher ampacity. Thirdly, insulation type. The type of insulation surrounding the wire also plays a significant role in determining its ampacity. Different insulation materials have different temperature ratings. Common insulation types include THHN, THWN, THW, and UF. THHN insulation is heat resistant and suitable for dry locations. THWN insulation is moisture and heat resistant, making it suitable for wet locations. UF cable is designed for underground applications and is moisture resistant. The insulation's temperature rating indicates the maximum temperature the wire can withstand without degradation. Wires with higher temperature ratings generally have higher ampacities. Fourthly, ambient temperature. The ambient temperature, or the temperature of the surrounding environment, also affects ampacity. As the ambient temperature increases, the wire's ability to dissipate heat decreases, reducing its ampacity. The NEC provides correction factors to adjust the ampacity based on the ambient temperature. For example, if a wire is rated for 30 amps at an ambient temperature of 30 degrees Celsius, its ampacity may need to be reduced if the ambient temperature rises to 40 degrees Celsius. Fifthly, installation method. How the wire is installed can also affect its ampacity. Wires installed in free air can dissipate heat more easily than wires bundled together in a conduit or enclosed space. The NEC provides tables that specify ampacities for different installation methods. For example, a wire installed in free air may have a higher ampacity than the same wire installed in a conduit with other current-carrying conductors. The National Electrical Code, or NEC, provides tables and guidelines for determining the appropriate wire size and ampacity for various applications. These tables take into account the factors mentioned above, such as conductor material, insulation type, ambient temperature, and installation method. It's crucial to consult the NEC to ensure that the wiring is safe and compliant with local regulations. The NEC ampacity tables list the allowable ampacities for different wire sizes and insulation types under specific conditions. These tables are essential for selecting the correct wire size for an electrical circuit. In addition to the ampacity tables, the NEC also provides correction and adjustment factors to account for variations in ambient temperature and the number of current-carrying conductors in a raceway or cable. When the ambient temperature is higher than the specified rating, a correction factor is applied to reduce the ampacity. When multiple current-carrying conductors are bundled together, an adjustment factor is applied to reduce the ampacity to prevent overheating. Now let's talk about safety concerns. Using undersized wires for electrical circuits can lead to several safety hazards. Firstly, overheating. When a wire carries more current than its ampacity rating, it can overheat. This can cause the insulation to melt or degrade, leading to short circuits, electrical fires, and equipment damage. Secondly, fire hazards. Overheated wires can ignite nearby combustible materials such as wood, paper, or insulation, leading to a fire. Electrical fires can spread quickly and pose a significant risk to life and property. Thirdly, equipment damage. Undersized wires can cause voltage drops, which can damage sensitive electronic equipment. Voltage drops can also cause motors to overheat and fail prematurely. Fourthly, electrical shock. Damaged insulation can expose live wires, increasing the risk of electrical shock. Contact with a live wire can cause serious injury or death. Fifthly, code violations. Using undersized wires violates electrical codes and regulations. This can result in fines, penalties, and the denial of insurance claims. It's essential to use the correct wire size for electrical circuits to prevent these safety hazards. Now let's discuss code violations. Installing an electrical circuit that does not meet NEC requirements can lead to several code violations. Firstly, improper wire size. Using undersized wires for electrical circuits is a common code violation. The NEC specifies the minimum wire size for different types of circuits and loads. Secondly, overcurrent protection. Failure to provide adequate overcurrent protection, such as circuit breakers or fuses, is another common code violation. Overcurrent protection devices protect the wiring from overheating and causing fires. Thirdly, grounding. Improper grounding is a serious code violation. Grounding provides a low resistance path for fault currents, reducing the risk of electrical shock. Fourthly, wiring methods. Using improper wiring methods, such as exposed wires or improper connections, is a code violation. The NEC specifies the acceptable wiring methods for different types of installations. Fifthly, accessibility. Failure to provide adequate access to electrical equipment, such as panels and junction boxes, is a code violation. Electrical equipment must be accessible for inspection and maintenance. Code violations can result in fines, penalties, and the denial of insurance claims. It's essential to follow the NEC and local electrical codes to ensure safe and compliant installation. Let's delve into recommended wire sizes. Determining the correct wire size for an electrical circuit is crucial for safety and performance. The NEC provides guidelines for selecting the appropriate wire size based on the load, distance, and other factors. To determine the recommended wire size, follow these steps. Firstly, calculate the load. Calculate the total current that the circuit will carry. This includes the current drawn by all appliances, lights, and other devices connected to the circuit. Secondly, determine the ampacity. Determine the required ampacity of the wire. The ampacity must be at least equal to the total current. Thirdly, select the wire size. Consult the NEC ampacity tables to find the appropriate wire size for the required ampacity. Consider the conductor material, insulation type, ambient temperature, and installation method. Fourthly, calculate the voltage drop. Calculate the voltage drop to ensure it is within acceptable limits. Use the voltage drop formula or online calculators. If the voltage drop is too high, increase the wire size. Fifthly, consider future expansion. Consider future expansion when selecting the wire size. It is better to choose a slightly larger wire size to accommodate future loads. For a 40 amp, 220 volts ball located 80 feet from the power panel, the recommended wire size is American wire gauge number 6 copper, which has an ampacity of 55 amps in air. This wire size will provide adequate ampacity and minimize voltage drop. Remember, it is always advisable to consult with a licensed electrician to ensure proper wiring and safety compliance. Electricians have the knowledge and experience to design and install electrical systems safely and efficiently. They can also help you comply with all applicable codes and regulations. Now some points about consulting with a licensed electrician. Consulting with a licensed electrician offers several benefits. Firstly, expertise. Licensed electricians have the knowledge and experience to design and install electrical systems safely and efficiently. They are familiar with the NEC and local electrical codes. Secondly, safety. Electricians are trained to identify and mitigate electrical hazards. They can ensure that your electrical system is safe and compliant with all applicable codes. Thirdly, compliance. Electricians can help you comply with all applicable codes and regulations. They can obtain the necessary permits and inspections. Fourthly, cost savings. Electricians can help you save money by designing an efficient electrical system. They can also help you avoid costly mistakes and repairs. Fifthly, warranty. Licensed electricians typically offer a warranty on their work. This provides you with peace of mind knowing that your electrical system is protected. When choosing an electrician, be sure to check their credentials and references. Ask for proof of insurance and licensing. Get a written estimate before work begins. Discuss the scope of work and payment terms. Communicate your expectations clearly. Following these tips will help you choose a qualified electrician who can provide you with safe and reliable electrical services. Here are some common electrical mistakes to avoid. Firstly, overloading circuits. Overloading circuits is a common mistake that can lead to overheating and fires. Avoid plugging too many devices into a single circuit. Secondly, using extension cords improperly. Using extension cords improperly can also be dangerous. Do not use extension cords as permanent wiring. Do not overload extension cords. Thirdly, ignoring warning signs. Ignoring warning signs such as flickering lights or sparking outlets can lead to serious problems. Have these issues inspected and repaired by a qualified electrician. Fourthly, DIY electrical work. Attempting do-it-yourself electrical work without proper training can be dangerous. Electrical work should be performed by a licensed electrician. Fifthly, neglecting maintenance. Neglecting electrical maintenance, such as inspecting wiring and replacing worn outlets, can lead to problems. Schedule regular electrical inspections to identify and address potential issues. Avoiding these common electrical mistakes will help you keep your home safe from electrical hazards. In summary, selecting the correct wire size is crucial for safety and performance. The National Electrical Code, or NEC, provides guidelines for determining the appropriate wire size based on the load, distance, and other factors. It is always advisable to consult with a licensed electrician to ensure proper wiring and safety compliant. Remember, safety should always be your top priority when working with electricity. When dealing with a 40 amps bus circuit located 80 feet from the panel, using American wire gauge number 10 wire is not only insufficient but also presents significant safety risks. The NEC clearly states that American wire gauge number 10 copper wire is only rated for 30 amps in free air. Exceeding this ampacity can cause the wire to overheat, potentially leading to insulation failure and even a fire. Moreover, the voltage drop calculation, while indicating less than 3%, might not fully account for the real-world conditions and the potential for even greater voltage drop under full load. The reduced voltage can negatively impact the spot's performance and lifespan. Therefore, it is essential to upgrade to American wire gauge number 6 copper wire, which is rated for 55 amps in air, providing a safe and reliable solution for the 40 amps bus circuit. Always consult a licensed electrician to ensure that all wiring complies with the NEC and local codes, guaranteeing a safe and functional installation.